Hello my dear students, welcome to IMS GATE Academy GATE Foundation course on digital circuit subject. So in this particular session we will discuss regarding Boolean algebra. This is the third session regarding Boolean algebra. So those who couldn't attend the previous sessions, so kindly watch those sessions in your free time. So first let us see what are the topics that we have covered in the last class. So in the last class we have discussed regarding simplification of Boolean functions. So regarding whatever the basic rules and laws of Boolean algebra we are having, like distributive law, consensus law and De Morgan's law, right? So whatever the basic rules and laws, with the help of that how to do the simplification, regarding that we have discussed variety of gate questions and we have discussed both conventional approach and shortcut approach also, right? And then we have discussed regarding min terms and max terms, and regarding these two properties regarding min terms and max terms we have given, okay, with the help of two variables we have generalized for n variables, right? So in this particular session we'll continue further. So this topic is common for all the four branches: EC, electrical, instrumentation, computer science. So kindly share this video link with all of your friends so that they also will attend this session in live and they also will get benefited from this session, right? So all of you quickly share this video link. So in the last class we have discussed regarding min terms and max terms for two variables. Once again I will make the tabular form, okay. After that we'll discuss regarding the properties of min terms and then properties of max terms, and then we'll continue further topics one by one. Say for example, if we are having two variables A and B, so min terms we will represent the notation as small m stands for min term, suffix I is nothing but the corresponding decimal equivalent of binary. Similarly, we will be having the corresponding max terms. We will represent max term as capital M suffix I. So here capital M stands for max term, okay. So when you are having two variables, you will be having four combinations of zeros and ones. So first of all, write those four combinations: 0 0, 0 1, 1 0, 1 1. Okay. So for any of these combinations, suppose if we are getting output as 1, that means the corresponding input combination we will consider as min term, okay. So say for example for 1 1 case, if we are getting output as 1, that time we will represent as A and B. When you substitute these two values here, you will get output as 1, okay. Here among the binary variables we are performing logical AND operation. Similarly for 1 0 case, A and B bar. For 0 1 case, A bar B. Similarly for 0 0 case, A bar B bar, okay. So whenever the variable value is 1, we have represented as normal form. Whenever the variable value is 0, we have represented as complement version, okay. Here when you are performing logical AND operation among the two variables, you are supposed to get output as 1, okay, right. So here in each and every logical AND term or product term, we are having two literals, and it is same as the number of given variables, that is 2, okay. Whenever the number of literals and number of given variables it is matching for any product term or logical AND term, we will call that particular product term or AND term as simply min term, okay, right. So this is one notation. This is the notation in terms of the variables. Now we are having one more notation like this, okay. Whatever the binary combination here we have considered, just represent the corresponding decimal equivalent. 0 0 is nothing but 0, 0 1 is nothing but 1, 1 0 is nothing but 2, 1 1 is nothing but 3. So whatever the decimal equivalent here you got, just you can put that value as suffix, that's all, okay. So that means this is your M0, then M1, M2, M3, okay. Sometimes in the questions you will be having the notation like this, or you will be having the notation like this, okay. From here small m stands for min term. Whatever suffix value you are having, that is nothing but the corresponding decimal equivalent of the binary, okay, right. Similarly Suppose for any of the input combination here, if you are getting output as 0, then the respective input combination will call it as max term. Okay. Here in order to get output as 0, say for example for 0 0 combination, here we want to get output as 0. That time we will write the expression like this: a plus b. Just substitute a value, b value, both are 0 here. 0 plus 0 means what? You are getting 0. Similarly, here for 0 1 case, a plus b bar, just substitute a value 0 and b value 1. Complement of 1 is 0. 0 plus 0 is what? 0. Okay. Similarly, for 1 0 case, you will get a bar plus b, and for 1 1 case, a bar plus b bar. So here if you observe, among the variables, we have performed logical OR operator. Here we have performed logical AND operation, whereas here logical OR operator. For any of the input combination, here you will get output as 0. Suppose if you substitute any of the input combination in these expressions, you will get output as 0. Say for example, last combination if you consider 1 1 case, 1 bar is 0, 1 bar is 0. 0 plus 0 is what? 0. Okay. Here you are having logical OR terms. In each and every logical OR term, you are having two literals, and it is same as the number of given variables, right? That is 2. Since the number of literals and number of given variables both are matching, then each and every logical OR term or sum term we will call it as max term. Okay. So this is one notation, and one more notation just like here. Just like the min term, we have represented with the small letter m, and suffix value we kept as what? Decimal equivalent of binary. In the same way, for max term we will use capital M. Regarding suffix value, same numbers. What are the numbers here you got? Same numbers. Okay. M0, M1, M2, M3. Okay, right. So for two variables we got 4 min terms and 4 max terms. Similarly, if you are having n Boolean variables, then you will be having 2 power n min terms and 2 power n max terms. These are the maximum possible min terms and max terms, because if you are having n variables, then you can write 2 power n combinations at the input side. So for each and every combination you can write, suppose if you are considering output as 1, that means the respective input combination is nothing but min term. Similarly, if you are considering for each and every combination, if you are considering output as 0, the respective input combination is nothing but max term, right? So that property we have discussed in the last class, and we have discussed one more property also. What is the relation between min term and max term? Suppose small m0, capital M0, small m1, capital M1, small m2, capital M2, small m3, capital M3. Don't tell that here we are having small letter m, here we are having capital letter m. No, I am not asking with respect to that sense. Okay. So just say for example, here you are having AB. How you are going to get A bar plus B bar? By performing which operation you are going to get this one? If you apply complement, AB whole bar is nothing but what? A bar plus B bar, by using De Morgan's law, right? Similarly, A into B bar whole bar is nothing but A bar plus B. In that way, even if you apply here complement, A plus B whole bar is nothing but A bar B bar, right? Either from left to right or right to left, if you apply complement of min term, you will get max term, or complement of max term is min term. Okay, so these are the two properties that we have discussed for generalized case in the last class. Okay, for each and every min term, if you perform complement, you will get max term, or for each and every max term, if you perform complement, you will get min term. Okay, right. Now in this particular session, let us continue further regarding the properties of min terms and then properties of max terms. Okay, first let us try to get the properties of min terms with the help of two variables. Let us get the properties, and from there we can make it generalized case. Okay, right. Say for example, for two variables we got 4 min terms. For the time being, let us perform the addition of all the min terms. What is the resultant value we are going to get? Let us see. So all of you put the heading properties of min terms. So for two variables we got 4 min terms. So let us perform the addition of all the 4 min terms, m0, m1, m2, m3, which is equal to just represent each and every min term in terms of the variables. M0 is nothing but a bar b bar, M1 is nothing but a bar b, M2 is nothing but ab bar, and M3 is nothing but ab. See, we are having two notations regarding min terms. This is one notation, this is one more notation. This is in terms of just small m stands for min term, suffix value is nothing but the corresponding decimal equivalent. So this is one more representation with respect to variables, right? A bar b bar, a bar b, ab bar ab. So just I have considered all the four min terms and I am performing addition. Okay. So regarding simplification, we already discussed in the last class. Whenever you want to do the simplification of any Boolean function, what is the first step? What is the first step? Before applying any law of Boolean algebra, whenever you want to do the simplification, what is the first step? In the last class I have mentioned. Yes, we have to observe the common terms. Sometimes there is a possibility to take entire term we can take common, or sometimes few variables we can take it as common, right? Whatever the possibility is there, try to take accordingly common, right? So that you can get the simplified function easily, because our motto is what? We want to get the simplified function, right? So that's why before applying any law of Boolean algebra, whenever you are supposed to find the simplification, that time just observe the common terms. If there is a possibility, try to take the common terms. If there is no possible, then by applying whichever law we can do the simplification, accordingly you can proceed. Okay, right. So for the time being, from first and second terms, you can take a bar as common. A bar if you take common, then you will get b bar plus b from remaining. Okay, a bar I have taken common from these two terms, then you are getting b bar plus b. Similarly, from last two terms, we can take a as common. From last two terms, we can take a as common, right? So then you will get b bar plus b. What is b bar plus b? B bar plus b is 1, right? So that means a bar into 1 plus a into 1. Okay, so a bar into 1 is nothing but a bar, plus a into 1 is nothing but a. So once again, just like b bar plus b, in the same way a bar plus a, once again you will get 1. Once again you will get 1. So that means what is your observation point? What is your observation point? For two variables, we got four min terms, m0, m1, m2, m3. If you are adding all the min terms, then resultant value you are going to get 1. If we are adding all the min terms, then resultant value you are going to get 1. This is the first property of min term. Okay, so just make a note. This is the first property of min term. Okay, sum of all min terms, is equal to 1. Sum of all min terms is equal to 1. Okay, so regarding sum, whenever you want to write in terms of expression or mathematical equation, okay, that time regarding sum or summation, we will use one symbol, that is sigma. Sigma stands for summation. Okay, sum of all min terms. Min terms means we will represent with small m suffix i. Okay, and here you are having I value, so it will start from 0 and maximum value will be 2 power n minus 1. See, if you are having n Boolean variables, then that time you will get 2 power n combinations of zeros and 1s. Since we are starting from 0, maximum value will be 2 power n minus 1. Maximum value will be 2 power n minus 1. Okay, write this minus 1 carefully. This is not in the power. Okay, suppose for two variables, total number of min terms you are getting 4, right? So 4 minus 1 is nothing but what? 3. So m0, m1, m2, m3. So all the min terms we are adding. Okay, it is ranging from 0 to 3. Similarly for n variables, okay, it is starting from 0. Maximum value will be 2 power n minus 1. Okay, so sum of all the min terms is equal to 1. So this is the first property of min terms. Okay, right. Now just observe this particular min terms column. If you multiply any two min terms, what is the resultant value you are getting? like M0 M1 or M1 M2, M2 M3 or M3 M0. Just consider any two different minterms. If you just simply multiply, then what is the resultant value you are going to get? See, it is very simple. Here B bar into B is what? 0. B into B bar 0, B bar into B 0, once again B into B bar 0. That means if you are multiplying any two different minterms, we are getting resultant value as 0, right? So this is the second property of minterm. So second property of minterm you can write down, product of any two different minterms, product of any two different minterms is equal to 0. If you are multiplying any two different minterms, resultant value you are going to get 0. Okay. Mathematically, if you want to represent, so we can represent like this. So Mi, Mj, I am considering two minterms, Mi, Mj. So I am just multiplying. Product means just, since I am considering only two, yes or no, two minterms, so you can multiply Mi into Mj, which is equal to 0 if I and j are not equal. If I and j are not equal, just like M0, M1, M1, M2, M2, M3, M3, M0. If you are multiplying any two different minterms, then you will get 0. Suppose if you are multiplying Mi with Mi, then what you will get? Or similarly Mj with Mj, what you will get? In that case, you will get the same minterm, yes or no? See, say for example, AB I have considered, that is M3. If you are multiplying with the same term, AB, A into A is nothing but A, B into B is nothing but B. That means you are getting once again the same minterm, just like X into X is nothing but what? X, right? So here, suppose if you consider, if J equal to I, here in the first case, if I and j are not equal, okay. In the second case, I have assumed j is nothing but I. That means Mi into Mi, you will get Mi. Suppose if you consider I equal to j, then Mj into Mj equal to Mj, like that, okay. So that means it is very simple. If you are multiplying any two different minterms, then resultant value will get 0. But if you are multiplying the minterm with the same minterm, then resultant value will be same minterm, like that. That's all. So this is the first property of minterms, the second property of minterms, okay. What are the properties here we are discussing? These properties we will apply when we are solving the questions based upon this concept, okay. Whenever you are having Boolean functions, that functions we can represent in sigma m form, like that. So regarding that concept we will discuss in some time. So that time if you are multiplying the functions, okay, so if you are having sum of minterms, like that two expressions are there, that time if you are applying these properties of minterms, you can easily solve the questions, or you can simplify the function, given function, you can do the simplification easily, right? So that's why these properties we will apply later, okay, right. I hope all of you got the clarity. For the timing I have considered, for two variables we got 4 minterms. With the help of that, in the first property what we have done, we have added all the minterms, okay. Resultant value we got 1, okay. Similarly, second property is what? We have multiplied any two different minterms, we are getting resultant value as 0. So what are the properties we have discussed? These properties will applicable for whatever may be the number of variables. For generalized case, it will applicable. For easy understanding, I have considered the example of two variables. With the help of two variables, we got 4 minterms, okay. With the help of that, we have got these two properties. These two properties we can generalize for any number of variables. I hope it is clear for everyone. With this understanding, now can you guess what are the properties for max terms? Just try to guess what will be the properties of max terms. So all of you put the heading properties of max terms and try to guess what will be the properties of max terms. Just observe the first property of min term. Just observe this sentence and tell me what will be the first property of maxterm. Yes, just observe here. Here you're having sum. Instead of sum, just replace with product. Okay. And here you're having min. Just replace with max. And here you're having 1. Replace with 0. Okay. Product of all max terms is equal to 0. Product of all max terms is equal to 0. Product of all max terms is equal to 0. Okay. So here product means what? We will represent the mathematical symbol as pi. Just like for sum, we have used the mathematical symbol sigma. In the similar way for product, we can use the mathematical symbol pi. Okay. Range will be same. I equal to 0 to 2 power n minus 1. 0 to 2 power n minus 1. Okay. And here max terms will represent capital M suffix I is equal to 0. Product of all max terms is equal to 0. Regarding min terms, we got sum of all min terms equal to 1. Just if you observe and just replace the main keywords. Okay. So from there you are going to get the first property of max term. Okay. Say for example, for 2 variables we got 4 max terms, right? For 2 variables we got 4 max terms. Okay. For the time being, let us verify whether this statement is correct or not. Say for example, for 4 variables we got, for 2 variables we got 4 max terms, right? So that means M0, M1, M2, M3. So we have to multiply these 4 max terms and we have to verify whether the resultant value, whether we are getting 0 or not. Okay, right. So just represent all these max terms in terms of the variables. So here M0 is nothing but A plus B. M1 is nothing but A plus B bar. M2 is nothing but A bar plus B. And M3 is nothing but A bar plus B bar. Just look at the tabular form. Earlier we have discussed for max terms column. Just you have to write. Okay. Now all of you do the simplification of this function. Already we have covered in the last class how to do the simplification. So with the help of that concept, so all of you give a try. All of you just do the simplification of this function and tell me whether you are going to get the resultant value 0 or not. Yes, I hope many of you are getting, right? Yes, it is very simple. You might have solved this particular function in conventional approach, like say for example, here if you observe you are having 2 bracket terms, you might have considered like A, you have multiplied with these 2 and similarly B with these 2. From there you will get some simplified function. After that, similarly you might have followed the same approach. After that you could have continued. That of course you will get final answer 0, but that will take more time. Now, here you can get the simplified function, the resultant value 0 easily by applying one of the law. Which law can you guess? In order to do the simplification of this particular equation, if you apply one law, you can get this answer easily in less time. Can you guess? Yes, we will use distributive law RHS to LHS. Okay, I will write down here regarding distributive law. Regarding distributive law, we have discussed this one. X plus yz equal to x plus y into x plus z. X plus y into x plus z. See, if you are having this expression, by applying distributive law, x plus y into x plus z. You can write like this. This is LHS. You can write into RHS. Suppose while you are solving any question regarding simplification of Boolean function, suppose if you come across the expression like this, if you are having the expression like this, you can write like this. Because if you are saying LHS equal to RHS, obviously RHS equal to what? LHS, right? So I am copying this one here. X plus y into x plus z is equal to, you can directly write this expression, x plus yz. How you can directly write? It is very simple. Regarding the proof of this one, we already covered in the first session regarding Boolean algebra. So kindly watch. It is very simple. You will consider x, you will multiply with these two, and similarly y, you consider y and multiply with these two and do the simplification. That's all. From there, you will get this one. Regarding that proof, we already covered in the first session of Boolean algebra. Okay, right. Now, instead of doing the proof for each and every time, whenever you are having an expression like this, of course, even if you are deriving, from there also you will get the same answer. But how to skip the derivation part? Okay, how directly we can write like this? It is very simple, very simple. Just observe these two brackets. Just observe these two brackets. In both the brackets, whichever part is common, just observe first and foremost that part. In these two brackets, x plus something, x plus y you are having, x plus z you are having. That means in both the brackets, x plus is same. So first of all, write that part as it is. First of all, write whatever the common part is there in both the brackets, write that one as it is. And then you can perform logical and among the remaining variables. Okay, so that means you are going to get yz. Okay, right. Now with the help of distributive law RHS to LHS, you can do the simplification of the Boolean function wherever required. Wherever required, if you can apply distributive law RHS to LHS, you can do the simplification. You can get the simplified function easily. Okay, right. Fine. Now just apply this distributive law RHS to LHS. Just observe these two brackets. Just observe these two brackets. Here a plus something, here also a plus something. So that means in both the brackets, a plus is the common part, right? So first of all, you can copy that one as it is. Copy that one as it is. Now we have to perform logical and among these two. That means b and b bar. Okay, right. Similarly, from these two brackets, just observe the common part. A bar plus something, a bar plus something. So that means in both the brackets, a bar plus is as it is. So you can copy a bar plus as it is. After that, just you have to perform logical and among these two variables. That means b into b bar. Just for understanding I have written, but directly you can write b into b bar is nothing but what? 0. Here also b into b bar is nothing but 0. Directly you can write, but just for understanding purpose, here you are having y and z. Similarly, you will get b into b bar. Here also b into b bar. I hope it is clear for everyone. So here you will get a plus b into b bar is what? 0. Similarly here a bar plus 0. That means you are getting a into a bar. A into a bar is nothing but 0. See, this particular step I have written here just for understanding purpose. But if you know this distributive law RHS to LHS, how to apply RHS to LHS regarding distributive law, okay, apply the same logic. Here a plus something, so you will write a plus as it is. After that, b into b bar is nothing but what? 0. Similarly, from these two brackets, you can write a bar plus is as it is. Because it is common part, a bar plus you can write as it is. Then b into b bar is nothing but 0. Okay, from this step, directly you can write this step. From this step, directly you can write this step. After that, what you are getting? A into a bar, that is nothing but 0. Right? Whatever here I have written, and for understanding purpose, I have written all the steps. But you can do all this kind of simplification in your mind itself. No need of pen and paper. Just observe the expression and directly you can say that the final answer you are going to get 0. Okay. Whenever you are getting like these expressions, wherever possible, try to do the simplification in the mind. Okay. You can, wherever possible, you can just avoid the pen and paper. Okay. If you are able to solve like that, then you can easily solve the digital questions in the GATE exam in less time. Otherwise, If you follow the conventional approach, definitely you'll get the correct answer, but it will take more time, right? So initially when you're learning the subject, try to learn the subject in conventional approach, but after you are getting good command over the subject, then try to contemplate whether we can solve the same question in less time or not. Okay, and whatever the basic concepts are there, with the help of fundamentals or with the help of some formulas, whether we can solve the same question in less time. When you contemplate, then you will get the ideas. Okay, wherever there is a possibility, try to simplify the same question or try to solve the same question with the help of shortcut, so that what are the shortcuts you are learning, okay, that will help a lot in the GATE exam. Okay, right. I hope it is clear for everyone. So regarding the first property of max terms, okay, so directly I have written the statement, that is product of all max terms equal 0. So for two variables we are having 4 max terms. I have just performed the multiplication and resultant value we are going to get 0. Yes, that means the first property is correct. Okay, what is that? Product of all max terms equal to 0. Product of all max terms equal 0. Now just look at the second property of min terms, and can you tell what will be the second property for max terms? Yes, see, whatever the main keywords here you're having, how you have replaced, in the same way just apply. Here you're having product, in place of product just keep some, and product of any two different, instead of min terms, now you can consider max term, right, is equal to, here you're having 0, replace with 1, replace with 1. That means sum of any two different max terms is equal to 1. This is the second property of max term. Sum of any two different max terms is equal to 1. Sum of any two different max terms is equal to 1. Okay, so mathematically if you want to represent, we are having two max terms here. Okay, mathematically you can represent mi, mj. So we are performing addition operation. So mi plus mj is equal to 1 if I and j are not equal. If I and j are not equal, we are getting 1. Okay, whether we are getting 1 or not, let us see. See, these are the 4 max terms. These are the 4 max terms for two variables, right? Now just perform addition of any two different max terms, like m0 plus m1 or m1 plus m2, m2 plus m3 or m3 plus m0. Just perform addition of any two different max terms. Here b plus b bar is what? 1. 1 plus anything is 1. Logical OR. Similarly, b plus b bar is 1. 1 plus anything is 1. Once again same approach. B plus b bar is 1. 1 plus anything is 1. Even from first and last also same. The moment if you are performing any two different max terms, the resultant value you are going to get 1. Suppose you are considering m0. If you are adding with m0, what you will get? Like a plus b is the term. If you are adding with a plus b, you will get the same term, right? A plus a is nothing but a, b plus b is nothing but b. That means the same term you are going to get. Okay, right. Yes, if you are adding two different max terms, then resultant value you are going to get 1. Okay, but if j equal to i, that means mi plus mi is nothing but mi. Don't write it as 2 times mi. Mi plus mi as 2 times mi. That will be okay in your normal mathematics, but here we are dealing about what? Zeros and ones. Okay, so here wherever you are having plus symbol, that is what? Logical OR operator. Logical OR operator. Okay, 1 plus anything is 1. Okay, or x plus x is x, like that. Okay, logical OR operation we are performing. Okay, if j equal to I, then you will get mi. Suppose if I equal to j, then mj plus mj is nothing but mj, like that. Okay, so these are the two properties of max terms. The first property is product of all maxterms equal 0, and the second property is sum of any two different maxterms equal to 1. I hope it is clear for everyone regarding the properties of minterms and properties of maxterms. These properties we will use when we are solving the questions related to this particular concept. Okay, right. Now let us see the next concept. This is very interesting. Algebraic expressions for Boolean functions. All of you put the heading algebraic expressions for Boolean functions. Okay. Say for example, whenever you are having the truth table, for easy understanding I am considering one simple truth table for two input case 0 0 0 1 1 0 1 1. Okay, so in general whenever you are designing any circuit or system, if it is related to digital, first step is what? You will determine how many input variables you require and how many output variables you require, and at the input side you will write all the input combinations in terms of zeros and ones, and based upon your requirement according to your specifications, okay, you will write for each and every combination according to the requirement. You can represent for few combination output as 0 and few combinations for remaining combination you can write output as 1, like that, right? Say for example, for the timing I am considering like 0 1 1 0. Okay, this is one truth table. Okay, here you are having inputs. For the timing I have considered only one output variable. Okay, right. So now how to represent this particular output variable? Okay, that is the question. Okay, regarding that we are having four varieties. Okay, we'll discuss one by one. So here first one is canonical forms. Canonical forms. Okay, so regarding canonical we'll be having two. Canonical sum of products form. Canonical sum of products form or sum of minterms form. Canonical sum of products form or sum of minterms form. This is the first case regarding canonical forms, and we are having one more form regarding canonical. Canonical product of sums form. Canonical product of sums form, or the other name for this one is product of maxterms form. Product of maxterms form. Canonical sum of products form or sum of minterms form. Other representation is canonical product of sums or product of maxterms form. Okay, so for the timing let us consider with respect to this wording. Okay, let us represent the output variable. Okay, say for example here output variable is y. So here output variable is y. So y is getting 1. Y is getting 1 for two combination of inputs. Y is getting 1 for two combination of inputs in this particular example. Okay, y is getting 1 for two input combinations, right? So here we have used the term minterm. That means for whichever input combination you are getting output as 1, the corresponding input combination is nothing but minterm. The corresponding input combination is nothing but minterm, right? So here in this particular truth table you are getting output as 1 only for two combinations. That means those two input combinations are nothing but what? Minterms. So here this is M1, this is M2. It is very simple. 0 1 is nothing but 1, 1 0 is nothing but 2. That I have kept as suffix. Since I am getting output as 1, the respective input combination is nothing but minterm. Minterm we will represent with the letter small m. Now what we have to do? We have to perform sum or addition of those minterms. So here y equal to m1 plus m2. Y equal to m1 plus m2. Okay. So here regarding sum, if you want, you can represent, you can use one mathematical symbol, that is sigma. Sigma stands for what? Sum. And small m stands for minterm. After that, whatever the minterm numbers here you got, just you can mention those numbers here. That's all. 1 and 2, right? So 1 comma 2. Like this you can represent. So here I have considered minterms sum together, or you can represent sigma symbol. Sigma stands for sum and small m stands for minterm. After that you can just mention the numbers. Okay. So these are the two varieties how to represent sigma m form or sum of minterms. And now if you want, you can represent these minterms in terms of the variables. So m1 is nothing but what? A bar b, and m2 is nothing but a into b bar. 1 is nothing but 0 1, right? You can look at here and you can directly write a bar b plus ab bar. A bar b is nothing but m1, ab bar is nothing but m2. Okay. Now just by looking at this expression, now you can say this expression is what? A XOR B. I hope all of you are familiar. Whatever the truth table here I have written, that is XOR gate truth table, right? A bar B plus AB bar is nothing but A XOR B. A XOR B. Okay. Now here if you observe, you are having two product terms or two logical AND terms. In each and every AND term or product term, we are having two literals, and it is equal to the number of given variables. Then those product terms we will call it as what? Minterms. And since minterms are summed together, it is what? Sum of minterms form or sigma m form. All are same. Sigma m or sum of minterms. Okay, right. Now for the same output variable, see, actually some of you may say that for these two input combinations we are getting output as 1. Okay. Now other students may say that for remaining combination of inputs, we are getting output as 0. Whether these two statements are same or different? All of you please respond. What I am saying is, some of you, so there are two set of students. Okay. One set of students are telling that for these two input combinations, we are getting output as 1. Okay. Now other set of students are saying that for the remaining input combinations we are getting output as 0. Whether these two statements are same or different, whether those two are representing the same output variable or different. Yes, it is representing same output variable only. Yes or no? See, if you are saying that for these two input combination, if output is 1, that means obviously for remaining input combination you are going to get 0, right? So that means for each and every output variable you can represent into any of the two forms. Okay. One form we already discussed. That means when you are having the truth table, you will just identify for whichever input combination you are getting output as 1, the respective input combinations are nothing but minterms. We will sum together. This is one form. Now let us see for the remaining combination of inputs. For remaining combination of inputs, you are getting output as 0. That means the corresponding input combination is nothing but what? Max term. So here it is M0, here it is M3. Right? Now here we have used the word product of max terms form. That means here in this truth table we got two max terms, we have to multiply. Y equal to, here we are having two max terms M0, M3, we have to multiply M0 and M3. Okay, just like here regarding sum we have used mathematical symbol sigma, right? In the same way regarding product we can use mathematical symbol pi. Pi stands for product. And regarding max terms we will represent with the letter capital M. Regarding min terms small m. In the same way for max term capital M. Now after that, whatever the max term numbers you are having, just represent here. That's all. 0, 3. So you can represent like this or you can represent like this. It is very simple. Product of max terms. Here we have considered max terms and we are multiplying. Here I have used the symbol regarding product, that is pi. Pi stands for product and capital M stands for max term. Okay. So these are the two notations regarding product of max terms. Now you can represent these max terms in terms of the variables. Can you tell what is M0, what is M3 in terms of A and B? All of you quickly respond. M0 is nothing but A plus B and M3 is nothing but A bar plus B bar. A bar plus B bar. Now tell me whether this equation and this equation, earlier we got this equation, right? Now we got equation for y like this. We got the equation for y like this. Now tell me whether these two are equivalent or not. All of you kindly check and respond whether this equation are equivalent or not equivalent. Yes, both are equivalent, right? See, some of you might be facing or still thinking that these two are not equivalent. But just observe, it is very simple. Here, A into A bar, what you will get? 0, 0. A into B bar, yes, we are getting this term, A into B bar. Next, B into A bar, we can write as A bar B by using commutative law. Yes, we are getting this term. Then B into B bar is what? 0. That means this function and this function both are equivalent only, but representation wise this is one form and this is another form. Okay, right. So that's why I have told earlier, whenever you are having the truth table, okay, you can represent each and every output variable either in first form or in second form, but both are equivalent only. Because see, ultimately each and every output variable either you can represent output as 0 or output as 1, right? So you can consider the set of the input combinations for which you are going to get output as 1. If you are considering like that, then you can represent the output expression like this form, or you can consider that the set of the input combination for which you are getting output as 0, you can consider those input combinations and you can represent the output function like this. Okay, both are functionally equivalent. Representation wise these two are different, but functionality wise, okay, when you do further simplification, this expression and this expression, final expression, whatever you are going to get, both are equivalent only, because ultimately you are representing for what? Y only. Whatever the output variable y you are having, the same output variable only we are representing, that's all, right? So in this way, based on the context, you can represent either this form or this form, or once if you are having this form, you can convert into this form like that, vice versa. Okay, say for example, for two variables, here I have considered number of variables are 2, okay. So if you are having two variables, that time you will get the range as what? 2 power n. 2 power n is nothing but 2 square, that is nothing but 4. So total you will get 4 minterms, but since you are starting from 0, the maximum value will be what? 3, right? So 0 to, the range will be 0 to 2 power n minus 1. Okay, so that means 0 to, here if you consider it in place of n 2, then 4 minus 1, that is 3. So suppose if you are having two variables, then you will write in terms of zeros and ones like this. If you convert into decimal equivalent, you will get the range as what? 0 to 3. So within this range, if they specify that for these two input combination, if you are getting output as 1, that means for remaining combinations, obviously you will get output as 0. That means if you are having, say for example, if you are having the function like this, if you want to write this function, you can easily write. Here just observe 0 to 3 is the range. Within that range you are having 1, 2. That means other than these two, the remaining terms are simply 0, 3. Or similarly, if you are having like this, you can write like this, vice versa. Okay. So if you are having sigma m, you can convert into pi capital M. Or if you are having pi capital M, you can write into sigma m. Okay, I hope it is clear for everyone. Representation wise these two are different, but ultimately you are representing the same output variable. That means both are equivalent only. I hope it is clear for everyone, and I hope in fact all of you got the awareness that whenever you are having the truth table, okay, in general everyone will say this. If I ask you that identify this truth table, majority of you will tell that this is the truth table of XOR gate. But how you are getting that expression? How you are getting that expression for XOR? This is the concept. Okay, now just observe, just pay attention here. Here I have considered the word sum. Here I have considered the word product. Say for example, if you interchange these two words, then what will happen? See, here I have considered sum, here I have considered product. Instead of like this, if I could have kept product here and sum here, then what will be the resultant? What you are going to get the resultant? So all of you just verify once. Yeah, just observe here. Suppose instead of sum, if you could have considered product, then just multiply these two. M1, M2. That means A bar B, AB bar. You will multiply these two. B into B bar is what? 0. You are getting resultant function as what? 0. But according to the truth table, for these two input combinations, your truth table is saying what? Output as 1. But here, instead of sum, if you could have considered product by mistake, your entire answer you are getting 0. That means it is wrong, right? Similarly, here instead of product, if you have taken sum, then just add these two maxims. M0, M3, if you add, A plus A bar is what? 1. 1 plus anything is 1. That means final expression you are going to get 1. But according to truth table, for these two input combinations, for 0, 0 and 1, 1, truth table is saying that output is what? 0. Okay, according to truth table, you are supposed to get 0. But if you perform addition operation here, you are getting 1. Similarly here, instead of sum, if you consider product, you are getting resultant value 0, but according to truth table you should get 1. Okay, that's why here we have considered sum, here we have considered product. I hope it is clear for everyone. Okay, in this way, each and every concept, whenever you are learning any subject, try to learn the subject. Why only like this? Why not in any other way? Okay, in this way, if you learn the subject, you can enjoy while you are learning the subject. Otherwise, you are simply by hearting the subject. If you are by hearting the subject, you may feel that you are, you may be happy for a moment, but it won't give long term happiness, right? But if you learn the subject in this way, okay, by questioning why, then you can learn the subject, and while you are learning the subject, you can enjoy that subject, and that particular subject will become favorite for you. Okay, right? That is the very key point, especially whenever you are learning for any subject, especially for GATE. If you are strong on the basics, then only you can attempt the GATE questions, right? So that is a very, very important. Fundamentally, you have to be strong. That's why we are conducting this foundation course. So all of you kindly share this video links with all of your friends so that they also will get benefited by attending these sessions, right? Okay. So far we have discussed regarding output expression. We have discussed two forms. Whenever you are having the truth table, from the truth table, either you can represent this function or this function. Initially we can represent the output function any of the two forms. Okay, based upon your convenience, you can represent either in this form or in this form, or if you are having this form, you can convert into this one, or if you are having this form, you can convert into this one, like vice versa. Okay, right. Now, after this, whatever the original function you are getting from the truth table for each and every output variable, after doing simplification, you will get the simplified forms. Okay, right. So here you are having two forms will be there regarding simplified function. Okay, the first one is sum of products form. Sum of products form. Here in short you can represent this one as SOP. Sum of products form or SOP form. And the other one is product of sums form. Product of sums form, or in short you can call it as POS, product of sums form. Product of sums form. Okay. From the truth table, initially you will get either sigma m form or pi capital M, but after doing the simplification, you will get either this form or this form. Okay. Say for example, I am considering f is a function of 5 variables. Okay. After doing the simplification, okay, I am just giving some random example. So after doing the simplification, we got the expression like this: a bar c plus b into d bar e. Just observe here, initially we are having 5 variables. The given function, it is a function of 5 variables. Okay. Now after doing the simplification, we got 2 product terms. We got 2 product terms. In each product term, just observe how many letters you are having. Here number of letters is 2. Here number of letters is 3. Right. So that means the number of letters present in these product terms are less when compared to the total number of variables. When compared to the total number of variables, the number of literals present in these product terms are less. Okay. Whenever the number of literals is matching to the number of given variables, then only the respective product term or logical term we will call it as min term. The moment if that condition is not matching, simply you can call it as product term, right? Since we are adding those product terms, that means sum, right? So sum of products form, that's all, very simple. Okay. Similarly here I am just giving random example, f of a, b, c, d, e. Here also I am considering f is a function of 5 variables. I am just giving random example. After doing the simplification, suppose if you got the function like this. I am just giving random example. Okay, right. After doing the simplification, you got the function like this. Now just observe. Here you are having logical R term or sum term. Similarly, here also you are having logical R term or sum term. Right. So here number of letters is 2. Here number of letters is 3. But here number of variables is 5. The moment if number of letters is less when compared to the total number of given variables, then simply we will call that logical R term as simply sum term. That's all. Okay. So here one sum term is there. Here another sum term is there. These two we are multiplying. That's why we are calling it as product of sums form. Okay. Right. So that means in general, whenever from the truth table, if you have written the output variable in sigma m form, okay, after doing the simplification, you will get SOP. After doing the simplification, what will happen? Say for example, initially, suppose the function, it is you are having 5 product terms. Suppose initially 5 min terms are there. After doing simplification, suppose I got 2 terms. That means 3 terms are getting minimized. And sometime what will happen? In each and every min term, okay, or in some of the min terms, the number of letters getting minimized. That means simply we are calling it as what? Product term. That means here number of letters in a product term also getting minimized, right? So that's why here you are getting the function as what? Simply product terms are summed together. That's why in general, whenever you are considering original function from the truth table as sigma m, after doing simplification, you will get SOP. Similarly, if you are considering original function as pi capital M, that means product of max terms, after doing simplification, you will get POS. Okay. So if you are having sigma m, you can convert into pi capital M, or if you are having pi capital M, you can convert into sigma m, like this. Okay. So in the last class, we already discussed the questions regarding the first approach. That means if you are having sigma m, how to get the SOP, because we have done the simplification of functions, right? So in this particular session, we will focus the reverse. Say for example, if you're having SOP, how to convert into the original function, how to get the original function, or similarly if you're having POS, how to get the original function, like that. Okay. And of course, regarding this particular relation also we'll see. If you're having sigma m, how to write the pi capital M, or if you're having pi capital M, how to write the sigma m. Okay. I hope all of you got the idea that how the min terms or max terms are getting helpful in order to write the output function. Whenever you're having the truth table, you will be having number of output variables, each and every output variable, how to write the Boolean function, right? I hope all of you got the significance of min terms and max terms. Okay, right. Now with this understanding, all of you try this question. This is the MSQ. That means either one option or more than one option can be correct. Yeah, time up. It is a simple question, but this question is of MSQ. That means either one option or more than one option can be correct. So you have to verify each and every option whether it is really correct or not. Okay, right. Whereas for MCQ, the moment if you are getting any correct option, suppose the moment you are getting option A is correct, so you no need to verify the remaining options. But whereas for MSQ, you have to carefully evaluate whether really that option is correct or not. Like that, you have to verify each and every option. Okay, right. So here they have given, here you are having the Boolean function like this. Okay, y equal to sigma m 0, 3, 6, 7, 10, 12, 15. Okay, this is the function it is given. Now you have to identify the correct options. Choose the correct options regarding the Boolean function y. Okay, so here you are having 4 choices. Regarding this particular function, whichever options are correct, you have to choose that one. Okay, now you might be having one doubt that here y is the function it is mentioned, but here it is not mentioned how many variable function it is. But you can guess easily from here. Yes or no? Here you are having what? Min terms. You are having min term numbers. Here you are having, among all the min terms, the maximum min term number is what? 15. Among the given min terms, the maximum number is 15, right? So for representing 15, how many bits you require? For representing 15, how many bits we require? We require 4 bits, yes or no? 4 ones is nothing but 15, right? So that means we require 4 bits. So whenever they don't mention in the given function how many variable function it is, just observe the min terms. Suppose if it is a function of min terms. Similarly, if it is a function of max terms, among the given max terms, whatever the maximum value is there, just convert into binary. How many bits are required? You can consider that many variable functions. Simple. It is very simple. So if you are having 4 bits, you can write 16 combinations of zeros and ones. So for the timing, if you write the corresponding decimal equivalent, you will get 0 to 15. You will get 0 to 15. Total 16 combinations are there. So within this range, other than these numbers, remaining will be what? Max terms. See, here you are having sigma m. That means for these input combinations, we are getting output as 1. That means for remaining input combinations, we will get output as 0. So if you carefully observe, among option A, option B, you are having what? Pi capital M. So just now, previously we have mentioned that If you are having sigma m, we can write pi capital M, or if you are having pi capital M, we can write sigma m, vice versa, right? So now by looking at these two, option A, option B, so the given function is sigma m, you can write the corresponding pi capital M. Okay, so the first approach is what? You will observe within this range, other than these numbers, you can identify, okay, in these two choices, which choice or which function it is having other than these terms, remaining numbers, that will be correct. Okay, say for example, here if you observe 0 is present, so that means 1 2 are not there. Okay, 1 2 are present here and here also. Then 3 is present, 4 5 4 5, then 6 7 present here, 8 9 8 9, 10 is present here, 11, 12 is present, 13, 14 is not present here, so it should present. Then 15 it is present, so that means here you can eliminate. See, if you are observing the function from left to right, okay, so at last term only it is mismatch is there in these two. Okay, or what you can do whenever you are having choices, okay, suppose in these two choices both the functions are regarding pi capital M only, so just observe which particular combination is different, simple. Okay, so in this case this combination only different, except this one, remaining all in option A, option B, what are the numbers here in option A, you are having same numbers only. So that's why whichever numbers are getting differed, so there only you can observe, okay, so that you can get the answer quickly. Okay, right. So here, since you are having min term 15, obviously 15 should not be there in the max term, right? So obviously here if you observe 0 to 15, this is the range. Within this range, other than these terms, remaining all the terms we are having. See, why I have done from left to right? Because in order to verify whether all the numbers other than this particular, these numbers, whether I am getting all the remaining numbers within this range or not, in order to verify that I have done. Okay, I hope it is clear. So option A is correct. Option A is correct. Option B is wrong. Now, regarding option C and option D, if you observe, that is regarding number of max terms. Regarding number of max terms. Okay. So the moment if you are saying option A is correct, just count how many max terms we are having. Here 1, 2, 3, 4, 5, 6, 7, 8, 9. Total number of max terms are 9. So that means option C you can eliminate. Option D is the correct one. So for this question, two choices are correct. Option A and option D. Option A and option D both are correct. Okay. So whenever you are solving MSQ, so carefully observe whether each and every option, whether it is really correct or not. Okay. But the moment for MCQ question, the moment if you are getting any of the option as correct, so you don't need to verify or you don't need to cross check the remaining options. I hope it is clear for everyone. So with this understanding, let us proceed. This is the question asked in GATE EC 2015 in the set 2 for 2 marks. All of you give a try. Yeah. Here if you observe, they have given one Boolean function. It is represented in sigma m form. Sigma m form. That means sum of min terms. And here if you look at the choices, and even in the question also they have mentioned canonical product of sums. Canonical product of sums means pi capital M. Pi capital M they are asking. They have given sigma M form, they are asking equivalent pi capital M. Or even if you look at all the choices, here in the given function, it is a function of three variables, right? And here if you look at each and every bracket term, if you observe each and every bracket term, you are having simply logical R terms, and in each and every bracket term, you are having three letters. That means, so since you are having logical R terms, those are multiplied together, and each and every logical R term, the condition is satisfying regarding number of letters and number of given variables. That means here whatever the bracket terms you are having, all those are max terms, and we have multiplied. Whatever the choices you are having, all the choices are regarding pi capital M. Since this question is MCQ, obviously one option will be correct, right? So it is very easy. So what is the first step? Here just observe the given variables. You are having three variables. So if you are having three variables, the corresponding decimal equivalent, you will get 0 to 7. 0 to 7. This is the range you will get. Okay. So total, when you are having three input variables or 3 bits, you will get total number of combinations are 8. Okay. Since you are starting from 0, maximum value will be 7. Now, total number of combinations are 8. Okay. So out of 8 combinations, here how many combinations you are having? Regarding min terms, you are having 5 combinations, 5 min terms are there. So that means, see, here you are having 4 options. Without using pen and paper, straight away you can eliminate 2 choices. Can you guess? Which 2 choices we can eliminate without using pen and paper? Yes, we can eliminate option C and option D. Option C, option D we can eliminate. Why? Because here you are having 5 min terms. But when you are having 3 variables, you will get total 8 combinations. Out of 8 combinations, if you are saying that for 5 combinations, if you are getting output as 1, for remaining 3 combinations, you will get 0. That means number of max terms are 3 only. But in option C, option D, you are having 5. So that is the reason you can straight away eliminate option C, option D. See, this is the 2-mark question, but without using pen and paper, you are already able to eliminate the wrong choice. 2 wrong choices you are able to eliminate. Now only 2 choices are left over. Now you can easily select the correct answer without using pen and paper. See, you are able to get 2 marks easily, right? Without using pen and paper. Okay, fine. So just tell me what are the maximum numbers. Here you are having, so for the given function, the maximum numbers will be 0, 1, 2 are present, then 3, 4. After that, 5, 6, 7 are present here. So only 3 maximum. That is the reason we are able to eliminate 2 choices. Now let us verify among these 2 which one is really correct. Okay. So it is very simple. So 0 is nothing but what? Just write the corresponding binary. 0 is nothing but 000. 0 is nothing but 000. So if you are writing the max term, then how you will write? 000 is nothing but x plus y plus z. You can observe here. X plus y plus z. When you substitute these values, resultant value you are supposed to get 0 because these are the max terms. Okay. Next you are having 3. 3 is nothing but 0, 1, 1. You can observe this term. Here 0, 1, 1. Yes, you are having complement version. So just if you substitute, complement of 1 is 0, complement of 1 is 0. Okay. Similarly here for 4 is nothing but 100. Okay. So here you are getting 100. Yes, option B is the correct one. Okay. See, the moment with the help of first max term, that is max term 0, M0, with the help of that term, okay, the moment just you can observe, we have identified that this term is correct. Whether you are having this expression in this, whether do you have x plus y plus z in this? No. That means with the help of this starting max term itself, we are able to choose option B as the correct one. Okay, I hope it is clear for everyone. So with this understanding, all of you give a try. Next question. This is the question asked in GATE EC in the same year 2015 in set 1 for 2 marks. This is also 2 mark question. All of you give a try. See, in the previous question, if you observe the given function, directly it is mentioned sigma m form. Directly it is mentioned sigma m form. Okay. But here in this question, they haven't mentioned the given function is sigma m. But you can guess how. You can observe here, it is a function of 3 variables. And in each and every product term, how many letters you are having? 3. So, the moment the condition is satisfied, that particular product term are nothing but what? Min terms. So, here the given function is in sigma m form only. It is very simple. Whenever each and every logical unterm, if you are having number of letters is same as number of given variables, that means the given function is sigma m. Okay, right. So, just write the min term numbers. Here, wherever complement is there, the corresponding variable value is 0. Okay, wherever normal means variable value is 1. Simple. 0, 1, 0, that is nothing but 2. Next, 1, 0, 0 is nothing but 4. Then 1, 1, 0 is nothing but 6. Then 1, 1, 1 is nothing but 7. So, just by observing that the given function is in sigma m form and you are having 4 min terms, okay. So, for this question, whether with the help of this one knowledge, that means the number of min terms are 4, with the help of that knowledge, whether we can eliminate any of the options directly? No, because in this question, if you observe all the 4 choices, you are having number of max terms are 4. See, if you are having 3 variables, you will get the range as 0 to 7. That means 8 combinations you will be having. Out of 8 combinations, for 4 combinations are producing output 1. That means remaining 4 combinations will produce 0. In this particular question, you cannot eliminate even any single choice with the help of this one point. See, in the previous question, we are able to eliminate because here initially you are having 5 min terms. Okay, that means since it is a 3 variable function, only 3 max terms are sufficient. So, with the help of that, so we have straight away we have eliminated 2 choices. Okay, but here in this question, unfortunately, we cannot eliminate even single choice with the help of that knowledge. Okay, sometimes it is possible, sometimes may not possible. No worry. Now here you got min terms. Now just write the corresponding max term numbers. Pi capital M, within this range, other than these numbers, remaining will be max terms. Okay, so 0, 1, 2 is present, 3, 4 is present, 5, 6, 7 already present. So 0, 1, 3, 5. Okay, so you can verify easily option by option. Suppose for the timing I am considering option A. Okay, so here x plus y plus z, that means 000. 000 is nothing but 0. Yes, we are getting this term. Okay, next 0, 0, 1. Complement is there, here 1. Yes. See, when you substitute this 1 bar is what? 0. It is very simple. Regarding min terms, when you represent the corresponding input combinations in that corresponding expression, you will get out plus 1. Whereas for max term, when you substitute these values, you should get out plus 0. Okay. Even in the exam, if you are getting any confusion, whether like this or like this, okay, whether we have to take complement or whether we have to take normal, or whether the variable value is 1 or 0, even if you are getting slight confusion, no need to worry at all. Okay, it is very simple. Whatever the term you are getting, whatever the term you are considering, when you are substituting the corresponding input combination, for min term you should get out plus 1, whereas for max term you should get out plus 0. If you are getting like that, that means what is the notation you have considered, that is correct only. If you are getting ulta, then just take the opposite way. Simple. See here, for min term, whenever variable value is 1, normal function. Yes or no? Whereas here, whenever variable value is 1, complement version. Whereas here min term, whenever variable value is 0, complement version. Whereas here, if the variable value is 0, normal function. Okay. So just remember, for min term, exactly opposite for max term. Simple those. Okay. Next. So that means 0, 0, 1. That means we are getting this one. Next. Here you will get 0, 1, 1. That is nothing but 3. Yes, we are getting. Then 1, 0, 1. Yes, we are getting 5. So that means option A is the correct answer. So with the help of the number of max terms, okay, initially we are unable to eliminate even single choice, but the moment if you have written the max terms numbers, okay, after that when you started verifying option by option, luckily the option A is satisfying. Okay, right. So option A is the correct answer for this question. So far we have discussed how to do the conversion of sigma m to pi capital M. Similarly, the case for pi capital M to sigma m also. Now let us solve one question. Okay. So here just observe the, first of all, observe the given function. This given function is in which form? First observe the given function and tell me f of ABC equal to a plus b bar c. Now in this question, you are supposed to represent the given function in this form. Represent the Boolean function f of ABC equal to a plus b bar c in sum of min terms form and product of max terms form. See, for each and every output variable, we can represent in 4 possible forms, right? From the truth table, we will get either sigma m form, sum of min terms means sigma m, or product of max terms means pi capital M. Now, with the help of this one, now you can identify this function is in which form. See, total 4 forms we have discussed, out of which here already 2 forms mentioned. Other than these 2 forms, whatever the remaining 2 forms are there regarding simplified. So from that, just identify the given function is in which form. Yes, you can observe here. Here you are having what? Product term. In this product term, how many literals you are having? 2 literals. But here number of variables are 3. Okay. The moment number of literals are less, it is simply what? Product term. So product terms are summed together, it is SOP form. SOP form. So the given function is SOP. Now you have to convert that one into sigma m and then pi capital. Okay, right. So the given function is in SOP form. The given function is SOP form. Now we want to convert this one into sigma m. That means in each and every product term, you should have number of literals is same as number of given variables. Here in this function, it is a function of 3 variables, right? So that means here in each and every product term, you should have 3 literals. Okay. So here you are having only 1 literal, so you can multiply 1 2 times regarding B, regarding C. Similarly here B bar C you are having. So regarding A, it is missing, so you can multiply with 1. So how many literals are missing? That many times you can simply multiply with 1. Simple. Now, this one you can write in terms of B as B bar plus B. And similarly, this one you can write as C bar plus C. B bar plus B is 1, C bar plus C is 1. Whenever you are multiplying with 1, resultant term will remain same. Next. This one you can write as A bar plus A. Okay, right. Now we'll consider B bar, will multiply with these two. Similarly, consider B, multiply with these two. So here A term I am copying, keeping outside only. B bar C bar plus B bar C plus BC bar plus BC plus here multiply A bar with this one, A with this one. Okay. So A bar B bar C plus A B bar C. Now multiply A with all these 4 terms. Okay. So from here you will get A into B bar C bar, then A into B bar C plus A B C bar plus ABC. Okay, so from here you are getting 4 terms. Okay, now A bar B bar C, here you are having, whether the term is repeated, no, you can copy that one, A bar B bar C. Now here you are having A B bar C. Yes, you can observe here you are having A B bar C, here also A B bar C is there. So A B bar C, if you are adding with A B bar C, what you will get? You will get same term. So I already mentioned, whenever you are adding the same min term, just like x plus x is what? X only. So you can consider one term. Now if you observe, in each and every product term, you are having 3 literals, and it is same as what? The number of given variables. So whenever that condition satisfies, then each and every logical unterm or product term we will call it as min term. Correct? So this is one representation regarding f of ABC in the sigma m form. Now you can represent in terms of sigma m also, or in terms of the min term numbers summed together. Okay, right. So just write the corresponding binary values. 100, which is nothing but 4. Next 101 is nothing but 5. Next 110 is nothing but 6. 111 is nothing but 7. Next 001, which is nothing but 1. Just write in the ascending order. M1 plus M4 plus M5 plus M6 plus M7. 1, 4, 5, 6, 7. Okay. So this one you can write it as sigma m 1, 4, 5, 6, 7. Okay. So in the options you can have either this representation or this representation or this representation. All are equivalent only. All are representing sigma m form only. Sum of min terms. All are representing sigma m. See, here you are having in terms of the min term numbers. Min terms sum together. Here you are having sigma m. Sigma stands for sum of min terms. Min term numbers you are having here in terms of variables. Okay. So for the given function SOP, we got what? The corresponding sigma m. Okay. Once if you are getting sigma m, now we can write corresponding pi capital M. Yes or no? The moment you are getting sigma m, you can write pi capital M. Once again, it is a function of 3 variables. 3 variables means range is what? 0 to 7. So within this range, other than these numbers, remaining will be what? Max terms. So you can directly write f of ABC is equal to pi capital M. 0 is not present. Then 1, 2, 3 not present. 4, 5, 6, 7 are present. So pi capital M 0 to 3. Or this one you can write as multiplication of max terms M0, M2, M3. Or if you want, you can represent in terms of the variables. 0 is nothing but 000, A plus B plus C. Then 2 is nothing but 0, 1, 0, 0, 1, 0. And 3 is nothing but 0, 1, 1. 0, 1. So you can multiply the max terms. Now you can observe in each and every logical OR term you are getting 3 literals, and it is same as the number of given variables, right? So these three are the representation of pi capital M, or product of max terms. In this way if you are having SOP, in this way, if you are having SOP, you can get sigma m. You can get sigma m. Okay, previously I have mentioned that if you are having sigma m, after doing simplification, you will get SOP. Similarly, if you are having SOP, you can get sigma m. Okay, so once if you are getting sigma m, you can convert into pi capital M. You can convert into pi capital M. This is one method. Now, if you want to see, initially you are having SOP, but if you want to get pi capital M first, what should be your original function? Your original function should be POS. If you are having POS, from there you will get pi capital M. From pi capital M you can get sigma m, like that. Okay, I hope it is clear for everyone. So this is the first method. In first method, what we have done, we have considered the SOP expression. What is the given expression is there? That is in SOP. Okay, from there we got initially sigma m. With the help of sigma m, we have converted into pi capital M. Now, suppose if you want to get pi capital M first of all, try to convert the given function to POS. If you convert the somehow or other, if you are able to get POS form, then from POS you can get pi capital M first. After that, with the help of pi capital M, you can get sigma m, like that. Okay. Now all of you just tell me how to write the POS expression for this particular function. By using which law we can write for this given function, how to get the POS form, by using which law we will get. All of you just recall whatever the laws that we have covered in the first session of Boolean algebra. All of you just go through those laws and tell me by using which law we can arrange this function into POS form. Even I have already covered that law even in this session also. If you are very alert, then you can easily answer. By using which law we can convert this function into POS? Yes, very good. By using distributive law. Here you can apply distributive law. So you will get a plus b bar into a plus c. A plus b bar into a plus c. Okay. So now this is in what? POS form. Now this is in POS form. You can observe you are having some term, these two are product together, it is POS form. Now in this sum term or in this sum term, number of literals is less when compared to the total number of variables, right? So now we have to bring in each sum term, number of letters should be 3. Now can you guess what we will do here? In the previous case, what we have done? In the previous case, I have multiplied with 1. Now in this case, what we will do? We will do simply add zeros, that's all. Based on the number of letters missing, accordingly you can add that many zeros. Here C is missing, regarding that you can add 1 0. Here B is missing, regarding that you can add 1 0. Okay. Now, this 0 you can write in terms of C as C into C bar or C bar into C, anything is fine. Okay. Similarly, this 0 you can write as B bar into B. B bar into B. See, previously when you are multiplying with 1, resultant term will be same. Similarly, here when you are adding with 0, resultant term will be same. Okay. Here our intention is, initially we are having the simplified form. Now we want to get the standard form, right? So that's why we are adding what? Literals. Based on the requirement, we are adding the literals. Okay. In the previous class, whatever the questions we have done, that is regarding simplification. Now in this class, what are the questions we are discussing? That is from simplified form to the canonical form. Okay, right. Now once again, just observe here, if you are having the function like this, in order to get like this, we have applied distributive law, right? So same logic, just observe here, same distribute law only. A plus B bar, you can consider like single variable, x. Okay, after that you are having here product term. You can apply distributor like this. Okay, so that means you will get A plus B bar plus C bar into A plus B bar plus C. A plus B bar, that entire term you can consider single variable, x. Okay, here you are getting C bar, here you are getting C. Now similarly, here A plus C you can consider A plus C. Okay, a plus c, just like here a plus b bar, you can consider a plus c as single variable. Now once again you can apply distribute law. You can apply distribute law. So what you will get, a plus c plus b bar, okay, into a plus c plus b. I hope it is clear for everyone, right? Now here also if any term repeats, you can consider one time, because x into x is nothing but x, right? So which term is repeating? Just cross check. Yes, this term is repeating, right? You can consider one time. A plus b bar plus c, same term. X into x is nothing but x. You can consider one time. So now you are getting a plus b bar plus c bar, then a plus b bar plus c, then a plus b plus c. Now just write the corresponding max terms. Here 0, 1, 1, that is nothing but 3. Next 0, 1, 0, that is nothing but 2. Next 0, 0, 0, which is nothing but m0. Or you can write in the ascending order m0, m2, m3. If you want, you can write pi capital M 0, 2, 3. So in this way, if you are getting pi capital M, after that you can convert into sigma m, like that. Okay. So here you are having POS form. So from POS you will get pi capital M. From POS you will get pi capital M. After that, if you want, you can convert into sigma m, like that. Okay. So in the previous method, initially we are having SOP. So from SOP we got sigma m. After sigma m we are getting pi capital M. Similarly, if you want to get pi capital M directly, so first of all arrange the given function to POS. If you are having POS, you will get pi capital M, and with the help of pi capital M we can get into sigma m. Okay. So this is the conventional approach. For understanding purpose, I have discussed both the forms like POS to pi capital M or SOP to sigma m. Okay, both the methods in the conventional approach I have discussed. This is for understanding purpose. Once if you understand this method, if you are getting such type of questions in the GATE exam, you no need to solve these kind of questions in the conventional approach like this. If you solve like this, you will get the answer, but it will take more time. Now, how many of you are eagerly waiting to see the shortcut method, how easily we can write the min terms or max terms? Yes, I hope all of you are eagerly waiting, right? Yes. Now let us discuss the shortcut. It is very simple. So first of all, if you observe here, the given function is what? SOP form. SOP form. So if you are having SOP, you can convert this one into sigma m first, right? Okay. So first of all, write the variables order as it is. First write the variables order as it is. Whenever you write the min terms or max terms, the order of the variables is very, very important. So here consider term by term. Here the first term is A. That means here A value is how much? 1. A means A value is 1. Regarding BC it is missing. So if 2 bits are unknown, how many combinations you will get here? 4 combinations, right? 0, 0, 0, 1, 1, 0, 1, 1. For all these 4 combinations, A value remain 1 only. Okay, just write the corresponding min term numbers. M4, M5, M6, M7. Okay, right. Now consider the second term, that is B bar C. B bar C. Here B bar means B value is 0, C means C value is 1. Here A is missing. So if 1 bit is unknown, how many combinations you will get? 2 combinations, 0 and 1. So 0, 0, 1 is nothing but 1, 1, 0, 1 is nothing but 5. So whatever the min terms here you are getting, we have to add. Okay, sigma m form. That means if any min term repeating, you can consider one time. X plus x is x, right? So here m5 is getting repeated, you can consider one time. So you will get sigma m 1, 4, 5, 6, 7. Yes, we are getting the same, right? So in this way, you can easily get, or you can easily choose the correct option from the given choices. Okay, so if you are having sigma m, from there you will get if you are having SOP, you can get sigma m first directly. Similarly, if you are supposed to find pi capital M, try to arrange the given function to POS. Okay, so regarding this one, we already discussed. For the given function, we already converted into POS by using distribute law. So here a plus b bar into a plus c. A plus b bar into a plus c. This is the PYS form. Now, since you are having PYS, now we can get pi capital M directly. Okay, here also same approach. First write the variables order as it is. Now consider term by term. Here the first term is a plus b bar. That means here you have to consider with respect to maximum notation. When you are having a plus b bar, here a is normal, that means its value is 0, 0. And here b bar, b is complement version, that means b value is 1. When you substitute here, you will get resultant value will get 0. That is the notation we are following. Earlier, what is the notation here we have considered in for the variables, whether I have to consider 1 or 0, that is with respect to min terms, same notation. Okay. Similarly here with respect to max terms. Okay. Now here C is missing. So regarding C, 1 bit is unknown. That means you will get 2 combinations. C can be 0, C can be 1. So 0, 1, 0 is nothing but 2 and 0, 1, 1 is nothing but 3. You are getting 2 max terms here. Next, let us consider the other term, that is A plus C. A plus C. So here A value is 0, C value is 0, B value is missing, right? So regarding B, you will get 2 combinations. It can be 0, it can be 1. So 000 is nothing but 0, 010 is nothing but 2. Here also if any max term repeating, you can consider one time, because whatever max terms here we are getting, we will multiply. So M2 into M2 is nothing but M2 only. So here M0, M2, M3 we will multiply. That's all. So in this way, if you are having PYS form, you can get pi capital M first. Okay. And similarly, if you are having SOP, you can get sigma M. So if you are having sigma M, you can convert into SOP, and if you are having pi capital M, you can convert into PYS with the help of basic rules and laws of Boolean algebra that we already covered in the last class. So in this particular session, we are discussing the reverse. That means if you are having the simplified function, how to get the original function or how to get the truth table, like that. Okay. So in this particular session, we have discussed regarding the properties of min terms, properties of max terms, and then we have discussed whenever you are having the truth table. Okay. So for each and every output variable, how to represent the Boolean function. We are having 4 varieties or 4 forms. So we have discussed all the 4 cases, and then we have discussed the questions like how to convert sigma M to pi capital M or pi capital M to sigma M, and then regarding SOP to sigma M or PYS to pi capital M, etc. We have discussed all these questions in both conventional approach and shortcut approach. Okay. So I hope this particular session is very much helpful for all of you. If you want to know more shortcuts regarding digital circuit subject, so kindly just regarding zero fee program, you will regarding that particular link, it will be there in the description. So kindly just enroll for that program, and you can have the free content whatever available, and then based upon your interest, you can whatever the numbers which are scrolling here, you can contact and you can take the admission so that you will get maximum benefit. It will be very much helpful for your GATE preparation. So tomorrow we will be having one more session. Okay. So the timings will be 4 to 5:30. Okay. So in tomorrow's session, we will discuss regarding K-maps. So we'll meet you all in that session. So for the time being, I'm stopping here. Thank you, everyone.